In previous session, we discussed some important points related to work for energy, which are useful for JEE mains exam. And also we discussed some previous year questions. Now in this session, we are going to discuss some more questions which are given in previous years in work, power, energy. We see this question. A body of mass 50 kg is lifted to a height 20 meters from the ground in two different ways, as shown in the figures. The ratio of work done against the gravity in both the respective cases are. Come on. Work done against the gravity. Is it a point function or a path function? It is a point function. See here. Here the body is lifted to 50 meters. Sorry, 20 meters. Here also it is lifted to 20 meters. In both the cases, we ask it to find what is the work done against the gravity. If it is a friction surface, then the work done may be different. But it is given it is a smooth surface. So in both cases, the work done is same, that work done equal to mgh. Against the gravitational force, there is no other force is acting. Work done is a point function. It depends on initial and final force. Initial and final force. So option D is correct. Okay? Yeah. We go for the next one. You see this question? A rubber ball falls from height h and rebounds up to height h by 2. The percentage loss of total energy of the initial system as well velocity of the ball before it strikes the ground respectively are. Yes. This is a simple question you can say. The ball is falling from height h. At this height, the total energy of the ball is potential energy only, it is mgh. Again, it rebounded to height h by 2. At this position, energy is mgh by 2. So what is the loss? The percentage of loss in energy is, yes, half of energy is decreased. Therefore, 50% is the loss. Again, you ask it to find what is the velocity before it striking the ground. If you can remember already formula V equal to root 2 which you can write, or by applying law of conservation of energy, half mv square is mgh. This is the kinetic energy on the ground, and this is the potential energy. This is the total energy. At maximum height, it has kinetic energy 0, total energy is equal to potential energy. When it reaches the ground, potential energy is 0, the total energy is equal to kinetic energy. Using this, we can write V equal to root 2gh. So this is correct option. Yes. We go for the next question. Yes. The body of mass 2 kg begins to move under the action of time-dependent force given by F equal to 60I plus 60 square J Newton. The power developed by the force at the time T is given by. Yes, what is the formula for power? Power. Yes. Hmm? Okay. Yeah. Here it is given. Force is time dependent. Now I am writing power. Power equal to force into velocity or mass into acceleration into velocity. Or simply you can write this as momentum dot acceleration. Okay. Again, can I take the momentum or change in momentum is equal to integration of F dot dt? Yes. So this is just to integrate it, integration of 6ti plus 6t square j dt. Now you get this is integration of t is t square by 2, t square is t cube by 3, 6t square by 2i plus 6t cube by 3j. Finally, you get this is 3t square I plus 2t cube j. This is the value of mv. Again, what is acceleration? Acceleration can be written as F by m. So, acceleration is F by m. F is this and m is this. So, you get it is 6t divided by 2i plus 6t square by 2j. So, this is 3ti plus 3t square j. This is acceleration. Finally, I want power. Now we can write power. This is momentum dot acceleration. Just to substitute what is the momentum and what is the acceleration. 6t square I plus t2 cube j dot. What is the acceleration I got? 3ti plus 3t square j. That is the dot product. Finally, you get this is 3t square into 3t, 9t cube plus 6t to the power of 5. What? So, this is your answer. Is it clear? Okay. Okay, we go for the next one. Yeah, what is this problem? Please look at the problem. An artillery piece of mass m1 fires a shell of mass m2 horizontal. Instantly after the firing, the ratio of kinetic energy of artillery as well as the shell is. Can you do this? See, what is given in our problem is this fires a shell. The mass of this one is m1 and the mass of this one is m2. It fires horizontal. When it fires, what we Now we see this problem again. An artillery piece of mass M1 fires a shell of mass M2 horizontally. Instantaneously after the firing, the ratio of kinetic energy of the artillery and that of the shell is. Now, what is given in your problem? Yes, this is firing, mass of this is M1 and firing a mass M2. This is related to internal forces, firing. So what we can say? The momentum is constant from law of conservation of momentum, or I can say momentum of first one is equal to momentum of second one, or momentum of this body and this body are equal. You ask it to find what is the ratio of kinetic energy of artillery and the shell. What is the relation between kinetic energy and momentum? Kinetic energy equal to P square by 2m. Since this momentum is constant, I can write K1 by K2. Yes, K1 by K2 equal to M2 by M1. That is kinetic energy is inversely proportional to mass. Therefore, option B is correct answer. We go for the next problem. It's completed. Yeah. See the next one. A solid circular disc of mass 50 kg rolls along a horizontal flow so that center of mass has a speed 0.4 meters per second. The absolute value of work done on the disc to stop it is. It is very simple problem related to some basic idea. Now, what is given in your problem? Yes? A disc moving with some velocity v. Now, what is the work done to stop it? What is the work done to stop it? Yes, it is equal to its kinetic energy. So, kinetic energy of mv square. It's very simple problem related to basic idea. Yes, 50 kg and the velocity is 0.4 meters per second, 0.4 square. Now you get this is 50 into 0.4 square, 0.16, or 0.16 by 8, 0.08. Is it correct? So your answer is 4 joule. Is it correct? Yeah. We go for the next problem. Yes. This next problem. This is also a simple problem related to basic idea. The problem is a block of mass 1 kg pushed up a surface inclined to horizontal at an angle 60 degrees by the force 10 Newton parallel to the inclined surface as shown in figure. When the block is pushed up by 10 meters along the inclined surface, the work done against the frictional force is. Suppose in this problem, if I take work done equal to force into distance, force is 10 and the distance is 10 meters, it is equal to 100 Newton. Is it correct? No, it is not correct. This is the total work done by this force F. But in your problem, what is asked? Work done against the frictional force is asked. Just you have to find work done against the frictional force. Work done against the frictional force means frictional force into distance, that's all. Now, what is the frictional force here? Yes? Yeah, mg acting vertically down. This can be split into two components. One is perpendicular to the surface, another is parallel to the surface. This is mg cos theta, and this is mg sin theta. This is the normal reaction. So the frictional force, this is nothing but mu into r. So what is the frictional force here? Mu mg cos theta. This is the frictional force into distance. Now you substitute the values. Mu, the coefficient of friction, is it given? Huh? Yeah. It is 0.1. Where it is given? Yes. Mass is 1 kg. G is 10, it is given. Cos theta, cos 60. Cos 60 is 1 by 2. And the distance is 10. So finally you get, how much you are getting? 5 joule is your correct answer. This is your answer. Okay, we go for the next one. The next problem is, a particle is placed at point A. It's a frictionless track, ABC. It is gently pushed towards the right. The speed of the particle when it reaches the point B is, see here, from here to here the particle is falling freely, we can consider. Why we can consider falling freely? Because it is frictionless. So, can I take velocity for a freely falling body, root 2gx? Have you remembered this? Now, how much it is? Root 2 into 10 into. So what is the value of x? From here to here it is 1 meter. From here to here 0.5. So it is 0.5. So this is equal to root 10 meters per second. This is your answer. Suppose if this ball reaches this point, then what is velocity? Yes, velocity equal to root 2gh. H is equal to 1 meter you have to take. Then what I get? Root 20. Suppose if this ball reaches this point, then what is velocity? Yes, it is 0. Because it is a frictionless path. If it is a friction path, the problem will be different. Okay. We go for the next one. Yeah. Next problem. The bob of a pendulum was released from horizontal position. The length of the pendulum is 10 meters. Dissipates 10% of initial energy against the resistance. The speed with which the bob arises at the lowest point is. Now see what is given in your problem. This pendulum is released from horizontal position. This is 10 meters. Suppose we consider there is no air resistance. When it comes from this position to this position, here the energy is mgh. Here the energy is half mv square. All its potential energy converts into kinetic. Then we can write mgh is equal to half mv square, the total energy. But here what is given in your problem? 10% of initial energy. It is dissipated against the air resistance. That means When this spark coming to this position, here mgh, 10% is wasted, 10% is lost. Then what will be energy here? Can I take 90% remaining? Here it is 0.9 mgh. Now this is equal to half mv square. Now from this you find what is the velocity. Okay, m will get cancels. Then what is velocity you get? V equal to root of 1.8 into gh. Then what I get? Substitute it. 1.8. The value of g is given as 10. And h is the radius of the pendulum, it is 10. So velocity, how much we are getting? Root 180 meters per second. This root 180 meters per second, how we can write it? Can we write it as 6 root 5? Root 180. This is root of 36 into 25. That is 6 root 5. So option A is correct answer. This problem related to conservation of energy. Okay, we go for the next problem. Yeah. Almost all this problem is also related to conservation of energy. A bob of mass m is suspended by a light string of length L. It is imported a minimum horizontal velocity at the lowest point A, such that just completes half circle reaching the topmost position. The ratio of kinetic energy is at A and B. I think already you studied about vertical circular motion. Have you remembered it? Vertical circular motion. Have you remembered it? When a body is moving in a vertical circle, at this position, the minimum velocity root 5 gr. At this position, the maximum velocity root gr. Have you remembered this? So what is the ratio of kinetic energies from A and B? This position is A and this position is B. Yes? Kinetic energy at A. This is half mv square. Half mv square is 5gr. Kinetic energy at B. Half mv square is root gr. So the ratio we get kinetic energy at A to kinetic energy at B. 5:1. Simple. Of course, you are not aware of this formula. Using law of conservation of energy, you can derive it. Okay. Now in this, at this position, just to find what is the velocity at this position as well as what is the velocity at this position. You can derive it by using law of conservation of energy. Can you derive this? See here, at this position, the centripetal force and centrifugal force, you equate it. You consider tension is 0. So you get mg equal to mv square by r. Of course, in this case, r is L. Then we get v equal to root g L. Similarly, at point A, the body has only kinetic energy. At point B, the body has kinetic energy as well as the potential energy. Now, from law of conservation of energy, you can equate these two energies. So I can write half mva square. This is equal to half mvv square plus mgh. H is nothing but 2L. From this, we get M will get cancels. VA square, this is equal to VB. Already we got VB is root GL. That is GL by 2 plus 2GL. Or this is equal to 5 by 2 GL. Is it correct? This is VA square by 2 actually. VA square by 2 is 5GL. 2 gets cancelled. VA equal to root 5GL. The same result we use here. Now what is your answer? Yes. 5:1. Is it asked A to B? Yes. A to B means 5:1. B to A means 1:5. When we are answering these questions very carefully. Is it A to B or B to A? Sometimes related to this only we do the mistakes. Okay? Okay, we go for the next problem. Yeah. This is a simple problem related to basic idea. A block of mass 100 kg slides over a distance 10 meters on a horizontal surface. The coefficient of friction between the surfaces is 0.4. What is the work done against the friction in joules? Now this is sliding. Frictional force is acting. You ask it to find what is the work done against the friction. Simply work done against the friction ante? Yes. Frictional force into distance. It is mu mg into s. Suppose you ask it to find what is work done by the force. You take force into distance. Now what is work done by frictional force? This mu is 0.4, it is given. M is 100. The value of G. Okay. Here it is not given. G is 10. So you take the value of G is 9.8. And what is S? 10 meters. So finally you get how much? Okay, into 10 power 3 is there, 9.8 into 4. 9.8 into 4, approximately it is, just you take 10 into 4, 40, like that. 9.8 into 9.4. Yes. How much you get? 3.9. Is it correct? Just to check it. Okay. Suppose if I take the value of G is 9.8, you get approximately this is 3,920 joule. Suppose we take the value of G equal to 10, then what we will get? Mu mgs. Instead of this, you substitute 10, we are getting 4,000. Now you may ask a question. Either you have to select this or this. If in problem it is given G equal to 10, it is okay. Sometimes what happens, in problem it may not given, but before question paper, in instructions it will be given the useful constant value. From that you can take it. Be careful about it. So before going to exam, before taking exam, you should read instructions carefully. Either in instructions, the values of constants are given or not. It is also important. Of course, here it is a controversy. If I select that is answer or this is answer. Of course, here exactly it is not there, 3920. So I can take G equal to 10 and I can select it. But be careful. The value may be given in the instructions. You go through the instructions before writing the exam. Okay. Now we go for the next question. Yeah. The potential energy function of a particle in a region of space is given by U equal to 2x squared 3y cubed 2z. The magnitude of x component of force acting at point P equal to 1, 2, 3. Now, what is the relation between potential energy and force? You are writing potential energy is equal to minus F dot dx. Have you remember this? Then, what is force? Minus dou u by dou x. This is very important. Suppose if it is only along x-axis, I write minus dou u by dou x. Suppose if it is along x-axis, y-axis, z-axis, then how I have to write means force is equal to minus I dou by dou x, because force is a vector, plus j dou u by dou y, plus k dou u by dou z. Like this you have to write. Or I can write force is equal to gradient of potential energy, grad u. This is called gradient. Important. The meaning of gradient is variation of function with respect to distance. Suppose if I say rate of change, what is the meaning of rate of change? If you take dx by dt, that is rate of change. Rate of change means the variation with time. Gradient means the variation with displacement. At the same time, these are partial derivatives. You know differentiation. Do you know partial differentiation? Suppose if any function is there, if you are differentiating partially with respect to x, then the terms y, z, you take them as constants. So you ask it to find what is the magnitude of x component of the force. So simply if you find minus dou u by dou x, it is enough. Of course, minus is also not important. Magnitude is important. Then what is u? Yes, u equal to 2x square plus 3y cube plus 2z. Then dou u by dou x value is yes 4x. This you have to find at point P1, 2, 3. That is x value is 1. So force is equal to 4 you get. Now this is your answer. Good. Now we go for the next one. A ball suspended by a thread swings in a vertical plane so that the magnitude of acceleration in extreme position and lowest position are equal. The angle theta of the thread deflection at the extreme position will be what is given in your problem. Yeah. Say here, when this pendulum is moving, this is lowest position, we consider this is highest position. Now at highest position, See, suppose if I consider this is a simple problem. Ikkada acceleration 0, ikkada acceleration is maximum. Do you know this? But which acceleration? Yes, the acceleration normal direction, tangential direction is 0. But normal acceleration not equal to 0. Similarly, here also, tangential acceleration is given by g sine theta. Do you know this? Enduku? The mg is acting along this direction. This can be split into two components. This is mg cos theta, mg sine theta. So what is the acceleration at this position? G sine theta. That is at highest point, at the extreme position. This is extreme position. At extreme position, the acceleration is g sine theta. This is the tangential acceleration. Now, what is normal acceleration? It is 0. Normal acceleration 0. Why it is normal acceleration is 0? Normal acceleration is nothing but v squared by L. The velocity is 0 at this point. Now, when you come to this position, at lowest point, tangential acceleration, this becomes 0. But normal acceleration is v squared by L. This is important. Now, the question is actually, whatever the tangential acceleration at this position is equal to normal acceleration at this position. Then what I can write? V square by L equal to g sine theta. This is the condition. Again, what is v square value? What is velocity? Already we know that the work done to take this from this point to this point is mgl into 1 minus cos theta. Already we done this. Is it correct or not? So, from law of conservation of energy, what I can write? Half mv square. This is the kinetic energy at this point. And this is the potential energy at this point. The potential energy is mgl into 1 minus cos theta. So, m will get cancelled. So, what I get? V equal to 2gl 1 minus cos theta. The v square one. Now you substitute that. Then what I get? 2g L by L gets cancels. 1 minus cos theta. This is equal to g sine theta. Now from this, you find the value of theta. Then what I get? 2 minus 2 cos theta. This is equal to sine theta. From here on, is it correct? What minus cos theta can be written as? 1 minus cos theta can be written as 1 minus cos theta can be written as identity. 1 minus cos theta identity. What is the identity related to 1 minus cos theta? Okay. 1 minus cos theta you can write is 2 sine square theta by 2. And sine theta you can write it as 2 sine theta by 2 cos theta by 2. Okay. Now 1 sine will get cancels. So sine theta by 2 cos theta by 2. You get tan theta by 2. This is equal to what you get? Tan theta by 2. Yes, we are getting it is 1 by 2. Then theta by 2 equal to tan inverse 1 by 2. So your theta is 2 tan inverse 1 by 2 is your answer. Okay. We go for the next problem. Okay, this is very simple problem related to basic concept. Two bodies of masses 4 grams and 25 grams are moving with equal kinetic energies. The ratio of magnitude of their linear movement. Yes, what is the relation between kinetic energy and linear momentum? P square by 2. If K is constant, P square proportional to M or P1 by P2 equal to root of M1 by M2. So in this problem, it is root, is it 4 by 25? So 2 by 5, C is your answer. Now we go for the next one. Yeah. A body released from height equal to radius of the earth. The velocity of the body when it strikes the surface of earth will be. Very simple question. The body is released from a height equal to the radius of the earth. The height is r. So when it touches the ground, the velocity will be root 2 GRS. This is correct. Directly you can write it. Is it correct? Yeah. Think once again. Yeah. Now let us check. V equal to root 2 GR. Is this answer is correct or not? That is our question. Now see here. This problem has to be solved like this. R, R. Now this body is at this position. Now it is falling towards Earth. At this position, body has only potential energy. Now what is the potential energy of this body? Minus GMM divided by 2R. From here I am taking. Okay. Next. When it comes to this position, surface of the Earth, it has potential energy as well as kinetic energy. So, on surface, the total energy equal to potential energy plus kinetic energy. This is nothing but minus GMM by R. Let us take this is half mv square. This is equal to total energy, this one. This is the total energy at this position. So this is equal to minus GMM by 2R. So what is half mv square? Half mv square equal to minus GMM by 2R plus GMM by R. Simply you get this is GMM by 2R. So what we are getting? V equal to GM by R. This is nothing but root GR. Now your answer is root GR. Now you may ask a question while doing the problems in kinematics. Suppose an object is falling from height h when it reaches the ground. We are, for a freely falling body, we are writing velocity equal to 2gh. Based on this, h is equal to r, v equal to root 2gr. You can write like this. It is correct. But it is not correct. Why it is not correct means we are considering this is 0 level. H is equal to 0 and H is equal to R. When this object coming to this position, complete its potential energy becomes to 0. That is our consideration. Have you understood? But here, in this case, now your 0 position is at the center of the earth. So surface of the earth means at height R. And this is at height R. From this we have to prove. Here, whatever the kinetic energy it gets, it is equal to change in potential energy. That is the difference between these two. This type of problems you have to solve like this. Okay? Okay. Is it clear? Okay, we go for the next one. A block of mass 10 kg is moving along x-axis under the force 5x Newton. The work done by the force to move x equal to 2 meters to 4 meters. This is very simple problem related to basic idea. Here it is given force is equal to 5x. That is force is dependent of displacement. Then what is work done we take? Yes, integration of f dot dx. The value of x is from 2 to 4. Simply you do it. It is 5x square by 2, 2 to 4. So this is 5 by 2 into 4 square minus 2 square. How much you get? Yes? Is it correct? Very good. Simple problem. We go for the next one. Yeah. This is also simple problem. A car accelerates from rest to u meters per second. The energy spent in this process is g joule. The energy required car to move from u2 to u. In first case, what is the energy required? Rest to u. The change in kinetic energy, that is the work done. Is it correct or not? This is half m square. In the second case, we have to accelerate from u2 to u. This is in first case. In the second case, this is given as E. In the second case, the change in kinetic energy. Half m to u square minus u square. How much you get? 3 into half m u square. You check it. So, what is the relation between E1 and E2? Can I take E2 equal to 3E? Then what is the value of this n? Yes, n equal to 3. This is simple question related to work done or energy. This is equal to change in kinetic energy. You go for the next one. Yeah, what is the next problem? The ratio of powers of two motors is 3 root x by root x plus 1 that are capable of rising 300 kg in 5 minutes, 500 kg in 2 minutes respectively from a well of 100 meters depth. The value of x will be. What is the formula for power? What is the formula for power? Have you remember? Power equal to work done by time. In first case, see here, it is given, it is used to lift water to some height. That is mgh by t. This is the general formula we take. Now, power of first motor by power of second motor. This is m1 g h. H is same by t1 divided by m2 g. Here also h is same by t2. So, can I take this is m1 t2 divided by m2 t1? Now, what is given in your problem? m1 t2 divided by m2 t1. This is the ratio of the powers. This is equal to 3 root x divided by root x plus 1. This is some printing mistake. Now, you ask it to find what is the value of x. You do it. Now, what you get? What is the value of m1? 300. T2, 2 minutes. This is m2, 50. T1, 5 minutes. Yes, 0, 0, 6, 12 by 5. This 12 by 5 value is 3 root x by root x plus 1. Then what will be the value of x? Is it 16? Suppose if I take x is equal to 16, root x, that is 3 into 4, 12. Root 16, 4. 4 plus 1, 5. So x is equal to 16 is our answer. Okay. We go for the next problem. Yeah, these are very important problems. This type of problems. A body of mass is given as 5 plus or minus 0.5. Velocity is given as 20 plus or minus 0.4. Then what is kinetic energy of mv square? Very simple. This is mass, this is velocity. We can write it is simply 1 by 2 into 5 into 20 into 20. How much you get? 5 into 10, 50, 50 into 20,000. Up to this, it is okay. Now the question is, it is given plus or minus something, it is given plus or minus something. Plus or minus, how much we have to write? It is important. This is very important. Now this type of problems, how to do very careful. This type of problem will be given. Say, what is mass given? 5 plus or minus 0.5. That means this is 5 plus or minus 0.5 means how much percentage of 5? This 0.5 is the percentage of error. Sorry, value of the error. Now, how much percentage of the error? Is it 10%? Is it 10%? Okay. Now, what is the velocity? 20 plus or minus 0.2. So, 20 plus or minus 0.2. What is the percentage of 0.2 in 20? And this is 0.2 by 200 into 100 and last time. So, what I get? Yes, it is not 200. What is the percentage of 0.2 in 20? What you write? 0.2 by 20 into 100 we write. So how much it is? Not 2. 1% we are getting. So it is 1%. Now, what is the percentage of error in energy? Percentage of error in energy. Now what is the percentage of error in energy? The formula is half mv square. You differentiate this. Already you done in errors. Now total error will be, can I take it is delta m by m plus 2 delta v by v? So it is delta m by m is 10%. This 10% is nothing but delta m by m into 100. This 1% is nothing but delta v by v into 100. Now this is 10 plus 2 into 1, 12%. Like this, you have to find the percentage of error. But in your problem, it is given, it is 20 plus or minus 0.4, not 0.2. If it is 0.4 means how much it is? 2%. Now this is 2%. So it is 14. So here this question mark is 14%. Now 14% of 1000, how much? Yes. 1000 plus or minus 140 joule. This is your answer. This type of problems are very important. Even in errors also, this type of questions will be given. The potential will be given 2 plus or minus 0.2 volt. Resistance is given 100 plus or minus 10. Now, what is the current? Like these questions will be asked. Good. This is the last question. What is the question given? To maintain a speed of 80 kilometer per hour, you have to maintain a speed 80 kilometer per hour. Mass of the bus is 500 kg. On a plain rough road for 4 kilometers distance, the work done by the engine by bus will be. And the coefficient of friction that is given as 0.04. We have to maintain, say here, we have to maintain constant velocity. To maintain constant velocity, force required 0, work done equal to 0. Is it correct? When this case is applicable, this is applicable if there is no friction. But here friction is there. So work done, this should be equal to work done by the friction. That is, work done is frictional force into distance. If there is no friction, to maintain the constant velocity, force is 0, work done 0. But frictional force is there. So we have to do work to overcome the friction. So this is equal to frictional force is mu mg and distance is s. Just to substitute the values, the value of mu is 0.04. What is the value of mass? 500. The value of g is, okay, you take it is 10. The value of s is 4. How much you are getting? 5,000 into 0.04 into 4. How much? Is it 1.6 or 0.16? Four into 0.04. Yes, 0.16. So it is equal to, you get 800 joule. Or this is 0.8 kilojoule. It is asked in kilojoule. Okay. And apart from this, we try to practice some more problems. Okay. And we meet in next session.